Hello there, and welcome to The Sleepy Scientist, a place where curiosity slows down and science becomes calm. Tonight, we gently turn our attention to one of the universe's most precise and steady objects, the pulsar star, a remnant of massive stars that now exists in a state of quiet rhythm and deep balance. Before we begin, allow your body to settle comfortably. Let your breathing become slow and natural. There is nothing you need to focus on, and nowhere you need to go. Pulsars do not rush, and neither do you. Whatever belonged to the day can soften and drift away. A pulsar is not defined by chaos or explosion, but by consistency. Born from the collapse of a massive star long ago, it now rotates with remarkable steadiness, sending out gentle beams of energy in predictable intervals. In the vast stillness of space, this rhythm feels more like a cosmic heartbeat than an event. As we continue, we'll explore the most relaxing facts about pulsar stars, how they form, how they maintain balance under extreme conditions, and how their steady rotation brings order to the quiet darkness around them. These facts are not meant to excite or overwhelm. They are meant to slow the mind, soften awareness, and allow rest to arrive naturally. If you enjoy these calm journeys through space and gentle science, you're always welcome to subscribe and return whenever you need quiet curiosity and rest. For now, simply listen, and let your thoughts drift alongside the steady, patient rhythm of a pulsar star. Let us begin. A pulsar begins its quiet existence after a massive star has completed a long life of steady fusion and gentle balance. When that star collapses inward, its outer layers drift away, and what remains is a dense core that no longer changes quickly. This core settles into a neutron star, and in some cases, it becomes a pulsar. From that moment on, the pulsar enters a phase defined not by chaos, but by remarkable regularity. Its rotation stabilizes, its structure becomes fixed, and it begins to exist as a steady presence in space rather than an active event. The rotation of a pulsar is one of its most calming qualities when viewed through a scientific lens. Once established, the spin becomes extraordinarily consistent, repeating again and again with almost no variation. Some pulsars rotate once every few seconds, while others rotate hundreds of times each second. Yet all do so with a precision that rivals the most accurate clocks ever built by humans. This consistency creates a sense of rhythm in deep space, where time feels measured not by urgency but by repetition. A pulsar's beams of energy are often described as sweeping through space, but this motion is not aggressive or chaotic. The beams are the result of magnetic alignment and rotation working together quietly. As the pulsar turns, its beams pass through space in smooth arcs, repeating the same path over and over. There is no acceleration or deceleration. Each rotation follows the last with gentle predictability, reinforcing the idea that even extreme objects can exist in states of calm order. The magnetic field of a pulsar is incredibly strong, yet it behaves in an orderly and stable way. Rather than fluctuating wildly, the field remains locked into the structure of the star, rotating with it and maintaining its shape. This magnetic stability allows the pulsar to continue emitting its signals without interruption. The field does not need to adjust constantly. It remains steady, guiding particles along invisible paths that repeat calmly through space. Inside a pulsar, matter exists in one of the most stable forms known in the universe. Neutrons are packed closely together, creating a structure that resists change. This internal stability means that the pulsar does not expand, contract, or fluctuate significantly over time. Once it forms, it remains almost exactly the same for millions or even billions of years, contributing to the feeling that it has reached a long-lasting equilibrium. The environment around a pulsar is shaped slowly and gently by its presence. Particles that approach are guided by magnetic influence, rather than pushed violently away. These particles follow curved paths, spreading energy outward rather than concentrating it. This creates a surrounding region that feels organized and calm, where motion exists but does not escalate into disruption. Pulsars are often found in regions of space that are otherwise very quiet. After the initial supernova has faded, the surrounding space returns to stillness, leaving the pulsar as a solitary, steady object. In this emptiness, its regular signals travel vast distances without interference. The silence around it allows its rhythm to continue uninterrupted, reinforcing the sense of isolation and calm that defines deep space. The timing of pulsar signals remains stable across immense spans of time. Scientists can predict the arrival of a pulse years in advance, knowing that the pulsar will not deviate from its established rhythm. This predictability allows pulsars to be used as reference points in space, acting as natural markers that remain steady even as galaxies slowly shift around them. A pulsar does not grow more active as time passes. Instead, it gradually slows, doing so at an almost imperceptible rate. This slowing happens evenly, without sudden changes. Each rotation becomes slightly longer than the last over millions of years, creating a gradual transition rather than a dramatic shift. This gentle deceleration reinforces the sense that pulsars age quietly. Even as a pulsar continues to emit energy, it does so efficiently and calmly. It does not flare unpredictably or release sudden bursts without cause. Its emissions follow the same pattern repeatedly, shaped by rotation and magnetic alignment. This repetition creates a sense of order, where energy flows outward in a controlled and consistent way. Across the universe, pulsars exist as reminders that extreme conditions do not always lead to chaos. Under immense gravity and density, they find stability. Their motion becomes rhythmic, their structure becomes fixed, and their presence becomes steady. They do not rush towards an ending, they simply continue, rotating patiently in the darkness, maintaining their quiet rhythm as time moves forward around them. A pulsar continues its existence in a state that feels almost timeless, where change happens so slowly that it blends into the background of the universe. After its formation, there are no sudden phases or dramatic transitions. Instead, the pulsar settles into a long period of stability, rotating steadily and maintaining its structure with remarkable consistency. This enduring balance allows it to remain unchanged for spans of time far longer than human history. The regular pulses we observe from a pulsar are not signals being actively sent, but natural consequences of its rotation. As the star turns, its beams of radiation sweep past Earth at precise intervals. This creates a gentle pattern of arrival and absence, like a distant lighthouse that never alters its pace. The calm predictability of this motion is one of the reasons pulsars feel soothing when described slowly and thoughtfully. Despite their extreme density, pulsars do not experience internal turbulence. The matter inside is locked into a rigid arrangement where particles resist movement. This rigidity prevents internal shifts and vibrations, allowing the star to maintain its shape and spin without disruption. Once equilibrium is reached, it remains, contributing to the overall sense of stillness that defines these objects. The space surrounding a pulsar is shaped gradually by its magnetic influence. Rather than pushing matter outward in sudden waves, the pulsar guides particles along curved magnetic paths. These paths repeat again and again, creating an environment of ordered motion rather than chaos. Energy spreads outward smoothly, dissipating gently into space. Over time, a pulsar's rotation slows by an extremely small amount. This slowing is so consistent that it can be measured with great accuracy, yet it never feels abrupt. Each rotation follows the last with almost the same duration, creating a long, unbroken sequence that changes only by tiny fractions. This slow evolution reinforces the sense that pulsars move through time calmly. Some pulsars exist in quiet companionship with other stars, orbiting them in slow, predictable paths. These binary systems are governed by gravity that remains constant and balanced. The motion of both objects becomes synchronized, forming a stable arrangement where change unfolds gradually rather than dramatically. The signals emitted by pulsars travel across enormous distances without losing their rhythm. Even after crossing thousands of light years, they arrive with the same spacing between pulses. This persistence allows pulsars to act as steady markers in the vastness of space, offering a sense of order in an otherwise open and silent universe. The magnetic axis of a pulsar remains fixed relative to its structure, contributing to the stability of its emissions. There is no wandering or shifting of alignment over short periods. This fixed orientation allows the pulses to remain consistent, reinforcing the feeling of repetition and calm continuity. Pulsars do not require external energy to maintain their rhythm. Their rotation is a stored motion from their formation, slowly released over time. This gradual release ensures that nothing about the pulsar feels rushed or forced. Energy flows outward naturally, without urgency. As millions of years pass, the pulsar remains largely the same object it was after settling into equilibrium. Its size, density, and structure remain unchanged. Only its rotation subtly evolves, doing so evenly and predictably. In this way, a pulsar exists as a quiet clock of the cosmos, marking time not through drama, but through steady repetition that continues without demanding attention or signaling an end. A pulsar continues its long existence as an object that rarely surprises its surroundings. Once its rotation and magnetic alignment settle, there are no sudden bursts of activity or unpredictable changes. Instead, the pulsar becomes defined by its reliability. Each rotation follows the last with calm precision, creating a pattern that repeats gently across millions of years. This steady repetition gives pulsars a uniquely peaceful quality among cosmic objects. The density of a pulsar contributes deeply to its stability. Matter within it is compressed to such an extent that movement becomes extremely limited. Particles are locked into place, resisting vibration and change. This internal stillness allows the pulsar to behave as a solid, unified structure rather than a shifting or evolving one. Once formed, it remains physically calm despite the extreme conditions it contains. The gravitational field of a pulsar is intense, yet it does not fluctuate. Gravity remains constant, holding the star together without strain or imbalance. There is no expansion or contraction cycle. The pulsar simply remains held in place by its own gravity, maintaining a quiet equilibrium that persists without adjustment. Around a pulsar, space itself feels ordered. Charged particles moving nearby follow predictable paths shaped by magnetic influence. These particles do not collide violently or scatter randomly. Instead, they trace smooth arcs that repeat over time, creating a surrounding environment where motion exists without disruption. Pulsars emit energy in a highly controlled manner. Unlike stars that flare or vary in brightness, a pulsar's emissions are shaped entirely by its rotation. This means there are no sudden increases or decreases in output. Energy is released in the same pattern again and again, reinforcing a sense of calm regularity. The temperature of a pulsar changes slowly over time. After its formation, it cools gradually, losing heat at a measured pace. This cooling does not involve sudden drops or instability. Instead, temperature decreases smoothly over millions of years, adding to the sense that pulsars age quietly rather than dramatically. In the vast emptiness of space, pulsars often exist alone. Their isolation contributes to their calm presence. With little nearby matter to interact with, there are few disturbances to alter their rhythm. Signals travel outward freely, unbroken by interference, allowing their steady pulses to move across space unchanged. Pulsars are so reliable that scientists can detect even the smallest irregularities in their motion. These irregularities are rare and subtle, often caused by internal adjustments that happen gently. Even these small changes do not disrupt the overall rhythm. The pulsar quickly returns to its established pattern, maintaining continuity. The alignment between a pulsar's rotation and its magnetic field remains constant for long periods. This alignment ensures that the pulses remain consistent in timing and strength. There is no wandering or instability in orientation, allowing the pulsar to remain a dependable presence in space. As time passes, the pulsar continues its slow rotation, releasing energy evenly and predictably. It does not move toward a sudden transformation or dramatic ending. Instead, it remains in this calm state for ages, quietly marking time in the darkness of space, maintaining its rhythm without urgency as the universe slowly evolves around it. A pulsar continues to exist as an object whose behavior is governed almost entirely by balance rather than reaction. Once its rotation rate is set after formation, there is very little that can disturb it. External influences rarely alter its motion, and internal changes unfold so slowly that they feel almost theoretical rather than observable. This allows the pulsar to remain a steady presence in space, maintaining the same rhythm while the universe around it changes gradually. The stability of a pulsar is reinforced by the way its mass is distributed. Nearly all of its matter is packed into a perfectly compact form, leaving no loose layers or unstable regions. There are no outer shells drifting away, no expanding gases, and no ongoing fusion reactions. What remains is a finished structure, one that no longer needs to adjust or rebalance itself. This completed state gives the pulsar a sense of permanence. Even the intense gravity of a pulsar behaves calmly. It does not fluctuate or pulse. It simply holds the star together with constant strength. This steady gravity prevents deformation and keeps the star's shape nearly perfect. There are no tides, waves, or oscillations within the star that might introduce instability. Everything remains held in place, quiet and unchanged. The rotation of a pulsar is so consistent that it can be compared across decades without meaningful difference. Scientists often describe pulsars as cosmic metronomes because their timing remains so precise. This precision does not come from active control or correction. It arises naturally from the pulsar's compact structure and conservation of angular momentum, allowing motion to continue without interruption. As a pulsar rotates, its magnetic field rotates with it as a single unified structure. There is no lag or distortion between the star and its magnetic influence. This unity ensures that the emitted beams remain aligned and predictable. Each sweep through space follows the same path as the one before, reinforcing repetition rather than change. The energy a pulsar releases is not chaotic radiation spilling outward. It is shaped and guided by magnetic geometry, emerging in narrow regions that remain stable over time. This controlled release prevents fluctuations in brightness or timing, allowing emissions to remain calm and repetitive rather than erratic. Pulsars also exist in an environment where time itself feels stretched. Because their changes occur over millions of years, they appear almost frozen when viewed over human lifetimes. Observations made decades apart often show nearly identical behavior, creating the impression that the pulsar exists outside ordinary time, continuing its motion without visible aging. The cooling of a pulsar adds to this sense of gradual evolution. After its formation, it slowly radiates away heat, but this cooling happens so evenly that there are no stages or milestones. Temperature decreases gently, blending into the background of time rather than marking noticeable transitions. Even when pulsars interact with surrounding material, the interaction remains controlled. Matter that approaches is influenced by magnetic and gravitational forces in predictable ways. Rather than colliding violently, particles are guided along paths that disperse energy gradually, maintaining order in the surrounding space. Through all of this, the pulsar remains unchanged in character. It does not progress toward a sudden transformation. It continues rotating, emitting, and existing in a state of steady balance. In the vast silence of space, this persistence feels calming, as if the pulsar has settled into a rhythm it will maintain quietly for ages to come, without urgency and without conclusion. A pulsar continues to exist as a reminder that even the most extreme objects in the universe can settle into calm, predictable states. After the turbulence of its formation has long faded, nothing about the pulsar's behavior feels hurried. Its rotation, emissions, and internal structure all move together in a steady balance, creating a presence that feels complete rather than evolving. The surface of a pulsar remains remarkably stable. Unlike stars that ripple with convection or flare with surface activity, a pulsar's outer layer is rigid and unmoving. There are no storms, no waves, and no shifting patterns. This stillness allows the star to maintain a consistent shape, reinforcing the sense that it has reached a finished form. A pulsar's magnetic poles remain fixed in relation to its body. This stability ensures that the beams of radiation it produces follow the same path through space over long periods. Each rotation recreates the same geometry, allowing the surrounding environment to experience the pulsar as a constant, repeating presence rather than a variable one. The energy loss of a pulsar occurs slowly and evenly. As it emits radiation, its rotational energy decreases by tiny amounts spread across immense spans of time. There are no sudden drops or irregular releases. This gentle energy transfer allows the pulsar to continue existing without disruption, gradually releasing what it carries without strain. The region around a pulsar often becomes quiet after its early life. Once nearby debris has dispersed, there is little matter left to interact with. In this emptiness, the pulsar's signals travel freely, uninterrupted by collisions or absorption. The surrounding silence enhances the sense of calm order created by its steady rhythm. The timing of a pulsar's pulses can remain accurate enough to serve as a reference for measuring time itself. This reliability does not require adjustment or correction. It emerges naturally from the pulsar's physical properties, showing how stability can arise without effort when conditions are balanced. Pulsars are unaffected by short-term events in the universe. Passing radiation, distant explosions, or shifting cosmic structures rarely alter their behavior. Their compact form and immense density shield them from external influence, allowing them to remain unchanged even as their surroundings evolve. The gradual slowing of a pulsar's rotation follows a smooth curve rather than steps. Each moment blends into the next, creating a continuous progression that feels more like a gentle drift than a process of decay. This slow change preserves continuity, ensuring that the pulsar never appears to break its rhythm. In binary systems, pulsars maintain their calm even while orbiting another object. Gravitational interactions remain predictable, following paths defined by stable physics. The pulsar's rotation continues unaffected by the motion of its companion, allowing both systems to coexist without disturbance. As ages pass, the pulsar remains largely what it has always been since reaching equilibrium. Its behavior does not signal a coming transformation or dramatic ending. It simply continues, rotating steadily and emitting its quiet rhythm into the darkness of space, existing as a calm, enduring presence while the universe around it moves slowly forward. A pulsar continues to exist in a state where balance has replaced motion as the defining feature. Once its early evolution is complete, there is nothing left for it to resolve or correct. Its structure, rotation, and magnetic alignment remain fixed in a quiet agreement, allowing the star to persist without tension. This settled condition gives the pulsar a feeling of completeness, as though it has already arrived at its natural form. The interior of a pulsar remains calm despite the extreme forces involved. Neutrons are packed so tightly that movement becomes nearly impossible, creating a rigid structure that resists change. This internal stillness prevents vibrations or internal shifts, allowing the star to behave as a single unified object rather than a collection of moving parts. The result is a deep sense of stability that lasts for immense spans of time. The relationship between a pulsar's gravity and rotation is finely balanced. Gravity holds the star together with constant strength, while rotation continues at steady pace. Neither force dominates or fluctuates. They coexist in equilibrium, maintaining the star's shape and motion without disruption. This balance ensures that the pulsar does not deform, wobble, or vary unpredictably. A pulsar's emissions remain consistent because they are not driven by changing fuel or internal reactions. Unlike stars that burn nuclear material, pulsars rely on stored rotational energy. This energy is released slowly and evenly, allowing emissions to continue without sudden changes in intensity or timing. The process feels controlled and unhurried, reinforcing the pulsar's calm presence. The space immediately surrounding a pulsar adjusts gently to its influence. Magnetic fields guide particles into orderly paths, preventing turbulence. These particles move along predictable routes, spreading energy outward gradually rather than concentrating it. This orderly motion creates a surrounding environment that mirrors the pulsar's internal stability. Pulsars rarely interact strongly with other objects once their early environment has settled. Without nearby matter to disturb them, they exist in relative isolation. This solitude allows their rhythm to continue uninterrupted, free from collisions or external forces that might alter their behavior. The vast emptiness around them enhances their sense of quiet persistence. Even when observed over decades, pulsars show almost no visible change. Their pulses arrive on time, their brightness remains steady, and their rotation continues predictably. This consistency across human timescales creates the impression that pulsars exist outside of ordinary change, continuing their motion independently of the passing years. The gradual slowing of a pulsar's spin does not introduce instability. Each decrease in speed is smooth and evenly distributed across time. There are no sudden pauses or jumps. This gentle deceleration preserves the rhythm of the star, allowing it to evolve without breaking continuity. The magnetic structure of a pulsar remains locked into its body, rotating as a single unit. There is no slipping or distortion between the star and its magnetic influence. This unity ensures that emissions remain aligned and predictable, reinforcing repetition rather than variation. As the pulsar continues through vast stretches of cosmic time, it does not anticipate an ending or transformation. It simply persists, rotating steadily and emitting its quiet signals into space. In the stillness of the universe, this persistence feels calming, a reminder that some things continue not by striving, but by remaining balanced and complete. A pulsar continues to exist as an object whose defining quality is endurance rather than activity. Long after its dramatic origin has faded into the distant past, the pulsar remains, turning steadily in the darkness. Nothing about its motion suggests urgency. Each rotation follows the last with calm certainty, creating a sense that time itself has slowed in its presence. The internal structure of a pulsar contributes deeply to this enduring calm. Matter inside is compressed into an arrangement so stable that it resists nearly all forms of disturbance. There are no internal flows, no rising or falling currents, and no shifting layers. Everything is held in a quiet stillness, allowing the pulsar to behave as a single solid entity rather than a changing system. The relationship between a pulsar's magnetic field and its rotation remains unchanged over long periods. The magnetic field does not wander or fluctuate independently. It turns with the star as part of the same structure, maintaining a fixed geometry. This unity ensures that the pulsar's emissions remain consistent, following the same path through space without variation. Energy loss in a pulsar happens so slowly that it feels almost theoretical, rather than observable. The star releases energy through its steady emissions, but this release is spread across millions of years. At no point does the pulsar seem to weaken suddenly or falter. Its strength fades gently, blending into the long flows of cosmic time. The environment surrounding a pulsar often becomes increasingly quiet as time passes. After nearby material has dispersed, there is little left to interact with. In this emptiness, the pulsar's presence feels solitary and calm. Its signals move outward unimpeded, crossing vast distances without interference or distortion. The precision of a pulsar's rotation is not something it actively maintains. It arises naturally from the conservation of angular momentum and the star's compact structure. Once established, this precision persists effortlessly, allowing the pulsar to remain one of the most reliable timekeepers in the universe without needing adjustment. Pulsars are largely unaffected by events happening far away. Explosions in distant regions, shifting galaxies, or changes in the cosmic background rarely influence their behavior. Their density and isolation shield them from disturbance, allowing them to remain unchanged while the universe evolves around them. The slow cooling of a pulsar adds to its quiet transformation. Heat escapes gradually, lowering the star's temperature over immense spans of time. This cooling does not involve stages or milestones. It proceeds smoothly, reinforcing the sense that the pulsar ages without drama. Even subtle changes within a pulsar occur gently. Occasionally, small adjustments in rotation can happen as the star settles internally, but these adjustments are minor and brief. The pulsar quickly returns to its established rhythm, maintaining continuity rather than disruption. As the pulsar continues its journey through time, it does not move toward a sudden end. It remains in this balanced state for ages, rotating patiently, emitting its calm rhythm into the vast silence of space. In doing so, it stands as a quiet reminder that stability, once achieved, can persist gently and endlessly without the need for change or conclusion. A pulsar continues its existence as an object that feels settled into a permanent rhythm. Once its rotation and structure stabilize, there is very little that can alter its behavior. This settled state allows the pulsar to remain predictable across immense spans of time, giving it a presence that feels calm and reliable rather than dynamic or restless. The balance between gravity and rotation within a pulsar remains remarkably steady. Gravity holds the star together with unwavering strength, while rotation proceeds at a constant pace. Neither force overwhelms the other. Instead, they coexist in quiet equilibrium, ensuring that the pulsar maintains its shape and motion without distortion or fluctuation. The magnetic field of a pulsar continues to guide energy in an orderly way. Charged particles follow magnetic lines smoothly, tracing paths that repeat again and again. This repetition creates a surrounding region of structured motion, where energy disperses gradually instead of concentrating. The result is an environment that feels organized and calm rather than intense. A pulsar's emissions do not vary randomly. Each pulse arrives as a consequence of rotation, not choice or reaction. This means that the pulsar does not respond emotionally or energetically to its surroundings. It simply continues its rhythm, unaffected by changes elsewhere in the universe. This detachment adds to the sense of tranquility that pulsars evoke. As time passes, the pulsar's interaction with space becomes even quieter. With fewer nearby particles to influence, its signals travel outward uninterrupted. The emptiness around it allows its steady rhythm to extend across great distances without distortion, reinforcing the feeling of isolation and stillness. The internal temperature of a pulsar continues to decrease slowly. Heat escapes at a measured pace, blending into the background of cosmic cooling. This gradual loss does not trigger sudden changes in structure or behavior. Instead, it allows the pulsar to age gently, maintaining stability throughout its long lifespan. Pulsars also demonstrate how extreme conditions can lead to calm outcomes. Despite immense density and gravity, the result is not chaos but order. Their compact nature removes excess motion, leaving behind a system that behaves with precision and consistency rather than unpredictability. The passage of time affects pulsars differently than it affects most objects. Changes occur so slowly that decades of observation reveal almost no difference. This slow evolution creates the impression that pulsars exist slightly outside of ordinary time, continuing their motion while everything else appears to change around them. Even when pulsars are part of binary systems, their internal rhythm remains unaffected. Orbital motion unfolds separately from rotation, allowing the pulsar to maintain its steady spin regardless of its companion's influence. This separation of motions preserves calm within complexity. As a pulsar continues through the universe, it does not anticipate an ending or transition. It remains in its balanced state, rotating patiently and emitting its quiet pulses. In the vast darkness of space, this persistence feels soothing, a reminder that once balance is achieved, it can endure calmly moment after moment without urgency or need for resolution. A pulsar continues its quiet existence as though it has settled into a final rhythm that requires no further adjustment. Once its spin, structure, and magnetic alignment have stabilized, the star no longer behaves like something in transition. It becomes instead a steady presence, repeating the same motion again and again with such consistency that change feels distant and abstract rather than immediate. The precision of a pulsar's rotation creates a sense of calm order in the vast openness of space. Each turn follows the last without hesitation, and the timing between pulses remains nearly identical over long periods. This regularity is not enforced by correction or feedback. It arises naturally from the pulsar's compact form, where physical laws express themselves with quiet clarity. Inside the pulsar, matter remains locked into a rigid state that allows no turbulence. There are no currents rising or falling, no layers sliding past one another. This internal stillness supports the star's external calm, ensuring that nothing inside disrupts the steady motion observed from afar. The pulsar behaves as a single unified object rather than a collection of competing processes. The magnetic field of a pulsar remains deeply anchored to its structure. It does not fluctuate independently or wander unpredictably. Instead, it turns with the star as part of the same whole, maintaining alignment across vast spans of time. This unity ensures that the beams of radiation remain consistent, reinforcing the pulsar's steady rhythm. Energy continues to leave the pulsar slowly and evenly. Rather than sudden releases, energy is carried away in small, regular amounts with each rotation. This gradual loss prevents instability and allows the pulsar to continue its motion without interruption. The process feels gentle and measured, as though the star is releasing its energy with patience rather than urgency. The space surrounding a pulsar often becomes increasingly quiet as nearby material drifts away. With fewer particles to interact with, the pulsar's influence spreads smoothly through emptiness. Its signals travel without resistance, maintaining their spacing and strength over enormous distances. This surrounding silence amplifies the sense of calm repetition that defines pulsars. Pulsars also demonstrate how time can stretch when change is slow enough. Over a human lifetime, their behavior appears almost unchanged. Pulses arrive on schedule, brightness remains stable, and rotation continues predictably. This slow evolution creates the impression that pulsars exist beyond everyday time, continuing calmly while everything else seems to move more quickly. Even the gradual slowing of a pulsar's rotation unfolds with remarkable smoothness. There are no sudden drops in speed, no irregular pauses. Each change blends into the next, preserving continuity. This gentle deceleration feels less like aging and more like a quiet settling into deeper stillness. In rare moments, small internal adjustments can occur within a pulsar, but even these are brief and subtle. The star quickly returns to its established rhythm, as though balance naturally reasserts itself. These moments do not disrupt the overall calm. Instead, they highlight how stable the system truly is. As the pulsar continues its long journey through the universe, it remains defined by steadiness rather than motion toward an end. It rotates, emits, and persists without anticipation or conclusion. In the immense silence of space, this ongoing rhythm feels deeply soothing, a reminder that some things continue not by striving forward, but by remaining perfectly balanced moment after moment, far beyond the reach of urgency. A pulsar continues its existence as a quiet expression of endurance, shaped not by ongoing change but by sustained balance. Long after its formation, there is no remaining instability to resolve. Its rotation, magnetic structure, and internal state have all settled into agreement, allowing the star to persist without internal conflict or external reaction. This harmony gives the pulsar a presence that feels calm and complete. The relationship between a pulsar's immense gravity and its compact size remains perfectly steady. Gravity holds every particle firmly in place, preventing expansion or distortion. There is no swelling or contraction, no rhythmic motion within the star's body. Everything remains fixed, reinforcing the idea that the pulsar has reached a state where forces no longer compete, but coexist quietly. The regular pulses observed from a pulsar continue to arrive as a natural consequence of rotation rather than activity. Nothing about the pulsar is actively sending signals. Instead, the star simply turns, and its beams pass through space in smooth, repeating arcs. This passive emission creates a soothing pattern, one that does not depend on external triggers or internal change. As time stretches onward, the pulsar's magnetic field continues to guide surrounding particles gently. These particles do not rush or collide. They follow curved paths defined by magnetic influence, dispersing energy gradually. The surrounding space remains ordered, reflecting the pulsar's internal stability rather than reacting to it. The slow loss of rotational energy remains evenly distributed. With each turn, the pulsar releases a small, predictable amount of energy. This release does not weaken the star suddenly. It unfolds across millions of years, allowing the pulsar to maintain its rhythm without interruption. Energy fades quietly, blending into the background of the universe. The isolation many pulsars experience contributes to their calm persistence. With little nearby matter to interact with, there are few opportunities for disruption. The pulsar exists alone in vast darkness, its signals travelling freely without interference. This solitude reinforces the sense that nothing presses upon it and nothing calls for response. Even when viewed over long observational periods, pulsars remain remarkably unchanged. Their timing stays consistent, their re-emission stable, and their rotation reliable. This constancy creates the impression that pulsars occupy a different relationship with time, one where progression is slow enough to feel almost still. The internal temperature of a pulsar continues to decline gradually, but this cooling does not alter its behavior. There are no sudden phase changes or structural shifts. Heat dissipates evenly, allowing the star to age quietly while maintaining its form and rhythm. The cooling process feels like a gentle settling rather than decay. Occasionally, a pulsar may experience a minor internal adjustment, but these moments are rare and brief. When they occur, the pulsar quickly returns to its established rhythm. Balance reasserts itself naturally, showing how deeply stability is built into the star's structure. As the pulsar continues through immense spans of cosmic time, it does not move toward a dramatic conclusion. It remains in its steady state, rotating patiently and emitting its quiet rhythm into space. There is no signal of an ending, only continuation. In the vast silence of the universe, the pulsar persists as a calm presence, maintaining its balance gently, moment after moment, without urgency and without need for resolution. A pulsar continues beyond its early life as a quiet demonstration of how extreme physics can settle into lasting order. After the collapse that created it, the star no longer rearranges itself or searches for balance. That work is already done. What remains is a compact object whose properties reinforce one another, allowing rotation, gravity, and magnetism to coexist without tension. This settled condition gives the pulsar a calm permanence that persists across vast stretches of time. The density of a pulsar plays a central role in maintaining this steadiness. With matter compressed to extraordinary levels, there is no room for internal motion to develop. Particles are held in fixed relationships, preventing the kinds of flows or instabilities seen in larger stars. This internal rigidity supports a smooth, uninterrupted rotation that does not wobble or drift, allowing the pulsar to keep time quietly in the background of the universe. The pulsar's magnetic field remains anchored deeply within its structure. It does not behave as an external feature that can detach or shift independently. Instead, it is woven into the star's body, rotating as part of the same whole. This integration ensures that the pulsar's emissions remain aligned and consistent, reinforcing the sense that nothing within the system is pulling in a different direction. Energy leaving a pulsar does so in a restrained and predictable way. Rather than releasing power in bursts, the star sheds energy evenly with each rotation. This steady release prevents sudden changes in behavior and allows the pulsar to maintain its rhythm for millions of years. The process feels patient, as though the star is letting go of energy at exactly the pace it can sustain indefinitely. The surrounding space adapts gently to the pulsar's presence. Magnetic influence shapes particle motion into smooth curves that repeat over time. These particles do not collide or scatter chaotically. They follow paths that encourage gradual dispersal of energy, maintaining an ordered environment that mirrors the pulsar's internal calm. Pulsars often inhabit regions of space that are otherwise still. After the remnants of their birth have dispersed, little remains nearby to disturb them. In this emptiness, the pulsar's steady signals travel outward freely, unchanged by interaction. The silence around it allows its rhythm to stand alone, uninterrupted and consistent. The gradual slowing of a pulsar's rotation continues without introducing irregularity. Each change in speed is tiny and evenly distributed across time. There are no abrupt pauses or shifts. This smooth deceleration preserves the pulsar's character, allowing it to evolve gently rather than dramatically. Even the passage of heat from a pulsar follows a calm trajectory. Cooling occurs slowly with no sudden thresholds or transitions. Temperature decreases blend into the background of cosmic time, leaving the pulsar's structure intact and its behavior unchanged. Aging becomes a quiet process rather than a visible transformation. In rare cases, slight internal adjustments may occur as the pulsar settles further into equilibrium. These events are subtle and brief. When they pass, the pulsar resumes its established rhythm, showing how deeply stability is embedded in its structure. Balance returns naturally, without the need for correction. As the pulsar continues through immense spans of time, it remains defined by continuation rather than destination. It rotates, emits, and persists without signaling a final stage. In the vast darkness of space, this ongoing steadiness feels soothing, a reminder that some objects do not hurry toward change, but remain calmly present, maintaining their rhythm as the universe slowly moves around them. A pulsar continues its long, quiet existence as an object that no longer seeks balance, because balance has already been achieved. Every part of the star works together in a settled arrangement where gravity, rotation, and magnetism reinforce one another rather than compete. This harmony allows the pulsar to persist without internal tension, existing as a stable structure that feels complete rather than evolving. The immense pressure inside a pulsar creates conditions where matter becomes almost motionless. Neutrons are packed so closely that movement is limited to the smallest possible scales. This lack of internal motion prevents turbulence or rearrangement, allowing the star to behave like a perfectly rigid body. The result is a sense of deep stillness at the heart of one of the universe's densest objects. The pulsar's rotation remains smooth because there are no flexible layers to introduce wobble or drift. With no outer atmosphere to shift or expand, the star turns as a single unified form. This cohesion ensures that each rotation mirrors the last, creating a rhythm that remains steady across millions of years. Nothing pulls ahead, and nothing falls behind. The magnetic field of a pulsar continues to function as an extension of its structure rather than a separate influence. It remains fixed in orientation relative to the star, turning with it as part of the same system. This stability ensures that the paths traced by emitted energy remain unchanged, reinforcing repetition and predictability. Energy emission from a pulsar follows a pattern that feels calm and reserved. The star does not flare or surge unpredictably. Instead, energy is released in small, regular amounts, carried outward by the rotation itself. This measured release prevents disruption and allows the pulsar to maintain its rhythm without interruption. The space around a pulsar reflects its steady nature. Magnetic influence shapes nearby particle motion into smooth, looping paths that repeat gently. These particles do not gather or collide violently. They move calmly, dispersing energy evenly and maintaining an environment of quiet order rather than intensity. Over time, the pulsar's presence becomes almost timeless. Observations made decades apart often reveal no visible change. The pulses arrive with the same spacing, the brightness remains steady, and the rotation continues predictably. This consistency creates the impression that the pulsar exists outside ordinary time, continuing its motion while change elsewhere feels more noticeable. The gradual cooling of a pulsar adds to its sense of calm aging. Heat leaves the star slowly, blending into the background of cosmic processes. There are no sudden thresholds where behavior changes. Cooling unfolds evenly, allowing the pulsar to remain structurally stable throughout its long life. Occasional internal adjustments can occur as the pulsar settles even further into equilibrium, but these moments are subtle and brief. When they pass, the star resumes its established rhythm almost immediately. These events do not disrupt the overall calm. Instead, they highlight how strongly balance is maintained. As the pulsar continues through vast spans of cosmic time, it does not move toward a dramatic ending. It remains in this steady state, rotating patiently and emitting its quiet rhythm into space. There is no sense of urgency or completion, only continuation, as the pulsar persists calmly, maintaining its balance while the universe slowly unfolds around it. A pulsar continues its existence as an object that feels deeply settled into its role within the universe. By this stage of its life, there is no remaining instability to resolve and no new structure to form. Everything about the pulsar reflects completion, from its compact shape to the unwavering pace of its rotation. This sense of final form allows it to persist quietly, without striving or transformation. The forces acting within a pulsar remain perfectly balanced. Gravity holds the star together with constant strength, while internal pressure resists collapse just enough to maintain shape. Neither force overwhelms the other. Instead, they exist in steady agreement, allowing the pulsar to remain unchanged across immense spans of time. This balance feels calm rather than tense, as if the forces have settled into long-term cooperation. The rotation of a pulsar continues without hesitation or interruption. There is no moment where the spin pauses or accelerates unexpectedly. Each rotation flows smoothly into the next, creating a continuous motion that feels more like a background condition than an active process. This uninterrupted movement reinforces the sense that the pulsar exists in a state of quiet continuity. The magnetic field remains deeply integrated with the pulsar's structure. It does not drift or weaken unevenly. Instead, it maintains its shape and alignment as the star turns, guiding energy outward in a consistent pattern. This integration ensures that nothing within the pulsar acts independently. All parts move together, reinforcing stability. Energy emission remains restrained and predictable. Rather than dramatic outbursts, energy leaves the pulsar in steady increments shaped by rotation. This measured release allows the star to maintain its rhythm without strain. The process feels patient, as though the pulsar has learned how to give without diminishing itself suddenly. The surrounding space continues to reflect the pulsar's calm influence. Charged particles nearby follow smooth magnetic paths that repeat gently. There is no build-up of tension or energy. Motion exists, but it is orderly and dispersed, mirroring the star's internal balance rather than challenging it. Time passes differently around a pulsar because change is so slow. Over centuries of observation, its behavior remains nearly identical. Pulses arrive on schedule and rotation continues with the same steadiness. This constancy creates the impression that the pulsar is not moving through time so much as existing alongside it. The slow loss of rotational energy continues evenly. Each moment contributes a tiny change that blends into the next. There are no sharp transitions or visible stages. This smooth progression preserves continuity, ensuring that the pulsar's rhythm remains intact even as it gradually evolves. In systems where pulsars share space with other objects, their internal behavior remains unaffected. Orbital motion unfolds separately from rotation, allowing the pulsar to maintain its calm rhythm regardless of external dynamics. This separation of influences reinforces internal stability. As the pulsar continues its long presence in the universe, it remains defined by persistence rather than direction. It does not move toward a final transformation or resolution. Instead, it continues rotating and emitting quietly, maintaining balance moment by moment, allowing time to pass without urgency, and remaining calmly present in the vast stillness of space. A pulsar continues to exist as a quiet anchor within the vast movement of the universe. By this stage, it no longer reflects the dramatic processes that once created it. Instead, it represents what remains after motion has settled and extremes have balanced themselves. Its presence feels less like an event and more like a condition, something that simply is steady and unchanged. The physical shape of a pulsar remains remarkably constant. There are no expanding layers or contracting shells, no visible deformation over time. Its compact form holds firm under immense gravity, creating a sense of completeness that does not require adjustment. This unchanging shape allows the pulsar to rotate without strain, preserving its rhythm without effort. The pulsar's rotation continues to act as a quiet measure of time. Each turn follows the last with calm certainty, forming a sequence that does not drift or wander. This repetition is not mechanical in feeling but natural, arising from the star's settled structure. It is motion without urgency, repetition without monotony. The magnetic field remains stable and deeply embedded within the pulsar's body. It does not flicker or fluctuate in strength over short periods. Instead, it rotates in unison with the star, maintaining a consistent geometry. This stability ensures that energy emissions remain predictable, reinforcing calm continuity rather than variation. Energy leaving the pulsar continues to do so in a controlled and balanced manner. There are no sudden releases or unpredictable changes. Each rotation carries away a small, even portion of energy, allowing the pulsar to persist for immense spans of time. This gradual release feels patient, as though the star has settled into a pace it can sustain indefinitely. The space around the pulsar remains shaped by order rather than disturbance. Magnetic influence guides nearby particles along smooth, looping paths that repeat gently. These particles disperse energy gradually, preventing build-up or collision. The surrounding environment mirrors the pulsar's internal calm, extending its balance outward. The slow cooling of the pulsar continues without visible consequence. Heat leaves the star evenly, blending into the background of cosmic processes. This cooling does not trigger structural change or alter behavior, it simply unfolds quietly, reinforcing the sense that the pulsar ages without drama. Over long periods, the pulsar's behavior remains so consistent that it can feel detached from change altogether. Observations separated by decades reveal nearly identical patterns. This constancy creates the impression that the pulsar exists slightly apart from time, maintaining its rhythm while everything else evolves more visibly. Even when subtle internal adjustments occur, they are brief and gentle. The pulsar quickly returns to its established rhythm, as though balance naturally restores itself. These moments do not disrupt the overall calm. Instead, they highlight how deeply stability is embedded within the star's structure. As the pulsar continues its quiet existence, it does not anticipate an ending or transformation. It remains in this balanced state, rotating steadily and emitting its calm rhythm into space. There is no sense of arrival or conclusion, only continuation, as the pulsar persists patiently, maintaining its order while the universe slowly moves around it. A pulsar continues its long existence as though it has fully settled into the quiet role it will maintain for the remainder of cosmic time. By this point, there is no lingering trace of instability or adjustment. The star no longer responds to change because there is very little left that can influence it. Its structure, rotation, and magnetic alignment have reached a state where persistence feels effortless. The balance inside a pulsar remains deeply ingrained. Gravity holds every particle in place with unwavering consistency, while internal pressure resists further collapse just enough to preserve shape. These forces no longer feel opposing. They exist in calm cooperation, allowing the pulsar to remain unchanged without tension. This equilibrium gives the star a sense of stillness that persists even under extreme conditions. Rotation continues as a smooth, uninterrupted motion. There are no pauses between turns, no acceleration or hesitation. Each rotation blends seamlessly into the next, forming a continuous flow that feels almost like stillness when viewed over long spans of time. This uninterrupted rhythm reinforces the idea that the pulsar has reached a stable pattern that does not need refinement. The magnetic field remains a quiet extension of the pulsar's body. It does not fluctuate independently or weaken unevenly. Instead, it rotates as part of the same unified structure, maintaining alignment and shape. This integration ensures that the pulsar's emissions remain consistent, repeating their paths through space without deviation. Energy loss continues at a measured and sustainable pace. With each rotation, a small amount of energy is carried away, spread evenly across time. There are no surges or irregular releases. This gradual process allows the pulsar to continue existing for immense durations, releasing what it carries slowly enough that continuity is preserved. The environment around the pulsar reflects its calm presence. With little surrounding matter to disturb it, space becomes quiet and open. Signals travel outward freely, maintaining their spacing and rhythm over vast distances. The emptiness around the pulsar amplifies the sense of isolation and tranquility that defines its existence. Cooling remains a slow and gentle process. Heat escapes from the pulsar at a pace that does not alter its behavior or structure. There are no thresholds where change becomes visible. Temperature decreases quietly, blending into the broader cooling of the universe rather than standing apart from it. Time continues to pass in a way that feels almost irrelevant to the pulsar. Over centuries of observation, its behavior remains nearly identical. Pulses arrive with familiar timing, rotation proceeds predictably, and emissions remain steady. This consistency creates the impression that the pulsar exists alongside time rather than being shaped by it. Even the rare internal adjustments that may occur are subtle and brief. When they happen, the pulsar quickly settles back into its established rhythm. Balance reasserts itself naturally, without external influence or correction. These moments do not interrupt calm. They reinforce how deeply stability is embedded within the star. As the pulsar continues through vast stretches of cosmic time, it does not move toward a final phase or resolution. It remains present, rotating steadily and emitting its quiet rhythm into the surrounding darkness. There is no urgency, no anticipation, and no conclusion, only steady continuation as the pulsar persists calmly, maintaining its balance while the universe slowly and silently evolves around it. A pulsar continues onward as an object that feels increasingly detached from change, as though it has settled into a quiet agreement with time itself. By this stage, nothing within the star seeks adjustment or release. Its rotation, density, and magnetic structure have aligned so completely that motion no longer feels like movement, but like a constant background state that simply persists. The interior of a pulsar remains profoundly calm despite the immense forces involved. Neutrons are held so tightly together that there is no room for internal motion to develop into turbulence. This rigid internal structure prevents waves, oscillations, or rearrangements, allowing the star to exist as a single, unified form. The calm within is absolute, reinforcing the steadiness observed from afar. Gravity within the pulsar continues to act with unwavering consistency. It does not pulse or fluctuate, it simply holds the star together, maintaining shape and density without effort. This constant gravitational presence contributes to the sense that the pulsar has reached a state where forces no longer compete but coexist quietly. The pulsar's rotation remains smooth and uninterrupted. Each turn flows naturally into the next, creating a rhythm that does not demand attention. There is no sense of progression or build-up. Rotation exists purely as repetition, steady and predictable, allowing the pulsar to maintain its presence without striving toward anything new. The magnetic field remains deeply interwoven with the star's structure. It does not wander or weaken in patches. Instead, it rotates as part of the pulsar itself, maintaining alignment and geometry across immense spans of time. This integration ensures that emissions remain consistent, reinforcing repetition rather than variation. Energy continues to leave the pulsar in small, evenly spaced amounts. This release is not a loss that destabilizes the star. It is a gradual easing, spread so thinly across time that it feels almost imperceptible. The pulsar gives without depletion, sustaining its rhythm while allowing energy to fade quietly into space. The surrounding region becomes increasingly empty and still. With little matter nearby, the pulsar's influence extends into silence. Its signals travel outward without resistance, maintaining their spacing and timing across vast distances. This uninterrupted travel reinforces the feeling that the pulsar exists in solitude, accompanied only by the quiet repetition of its own motion. Cooling continues at a pace so gentle that it does not alter the pulsar's behavior. Heat escapes gradually, blending into the slow thermal evolution of the universe. There are no thresholds or transitions that mark this cooling. It happens evenly, allowing the pulsar to remain structurally unchanged. Time itself seems to lose urgency around a pulsar. Over decades and even centuries of observation, its behavior remains familiar and unchanged. Pulses arrive when expected, rotation continues smoothly, and emissions remain steady. This constancy creates the impression that the pulsar exists outside ordinary temporal flow. As the pulsar continues its long existence, it does not approach a conclusion or transformation. It remains present, rotating steadily and emitting its quiet rhythm into the darkness. There is no final phase waiting ahead, only continuation, as the pulsar maintains its calm balance moment after moment, allowing the universe to move gently around it without disturbance. A pulsar continues to exist as a reminder that motion does not always imply change. Although it rotates continuously, nothing about its state feels transitional. The motion becomes a form of stillness, repeating so perfectly that it fades into the background of awareness. This kind of movement does not demand attention. It simply exists, steady and reliable, allowing the surrounding universe to drift and evolve independently. The balance within a pulsar is maintained without adjustment. Forces do not correct one another or compete for dominance. Gravity holds, internal pressure supports, and rotation continues, all without interruption. This equilibrium does not need reinforcement. It persists naturally, demonstrating how stability can emerge when extremes are fully resolved. A pulsar's presence shapes its surroundings quietly. Rather than disturbing space, it organizes it gently. Charged particles respond by following curved paths that repeat calmly over time. There are no sudden accelerations or collisions. Energy spreads evenly, maintaining order rather than creating disruption. The predictability of a pulsar's rhythm allows it to feel almost comforting when considered slowly. Each pulse arrives with familiar timing, reinforcing continuity. There is no surprise, no variation demanding response. This repetition creates a sense of trust, as though the universe itself is breathing steadily through the pulsar's motion. Inside the pulsar, matter remains locked in a state that resists all change. There is no melting, no flowing, no rearranging. This rigidity ensures that the star's structure remains unchanged for immense spans of time. The absence of internal motion contributes to the calm exterior behavior, allowing the pulsar to behave as a single, unified object. The magnetic field remains inseparable from the pulsar's identity. It does not weaken unevenly or shift unpredictably. Instead, it rotates in harmony with the star, maintaining alignment across countless rotations. This unity ensures that emissions remain consistent, reinforcing the pulsar's quiet regularity. The gradual release of energy from a pulsar feels less like loss and more like balance. Energy leaves slowly, evenly distributed across time. Nothing is depleted suddenly. The star continues comfortably within its limits, maintaining its rhythm without strain or urgency. Isolation often enhances a pulsar's calm presence. With little surrounding matter, there is nothing to interfere with its motion. Signals travel outward uninterrupted, preserving their spacing across vast distances. The emptiness around the pulsar allows its rhythm to remain pure and undisturbed. Cooling within a pulsar proceeds without consequence. Temperature changes do not alter behavior or structure. Heat fades gradually, blending into the slow cooling of the universe itself. This process does not mark stages or transitions, it simply continues quietly in the background. Even across cosmic timescales, a pulsar does not signal completion. It does not move toward a final state. It remains present, rotating steadily, emitting softly, and existing in quiet balance. The rhythm continues without urgency, without destination, allowing time itself to pass gently around it. A pulsar exists in a state where precision feels natural rather than engineered. Its rotation does not rely on adjustment or correction. Once established, the rhythm continues on its own, as if the universe itself has agreed to keep time through this object. The steadiness becomes part of the background of space, present without asking to be noticed. The forces within a pulsar are so perfectly balanced that change becomes unnecessary. Gravity compresses, internal pressure supports, and rotation stabilizes all at once. None of these forces rise or fall abruptly. They remain constant, allowing the star to persist without internal negotiation or conflict. The pulsar's rotation creates a sense of continuity rather than motion. Each turn mirrors the last so closely that individual rotations lose distinction. Over time, the spinning feels less like movement and more like a permanent state, a condition that simply exists alongside space itself. The magnetic structure of a pulsar remains remarkably ordered. Field lines do not tangle or drift. They hold their shape over long periods, guiding particles calmly along familiar paths. This order does not require maintenance. It is sustained naturally by the star's compact form and steady rotation. Energy leaving a pulsar does so without urgency. There is no sense of depletion or loss. Instead, energy fades outward gradually, carried away in small, consistent amounts. This gentle release allows the pulsar to continue existing comfortably within its limits, never approaching exhaustion. The surrounding space adjusts quietly to the pulsar's presence. Instead of reacting sharply, particles slow, curve, and disperse. Motion becomes smooth and predictable. The environment reflects the pulsar's internal calm, extending its balance outward into the darkness. A pulsar's internal rigidity prevents vibration or disturbance. With no layers sliding or shifting, the star remains silent within itself. This internal stillness supports the external rhythm, ensuring that nothing inside disrupts what is observed from afar. The passage of time feels softened around a pulsar because change unfolds so slowly. Decades of observation reveal almost identical behavior. Pulses arrive as expected. Rotation continues without drift. This constancy creates the impression that the pulsar exists outside ordinary time, continuing quietly while everything else evolves. Cooling continues without altering identity. As heat slowly escapes, the pulsar remains structurally unchanged. There are no thresholds where behavior shifts. The star ages without milestones, blending seamlessly into the slow thermal evolution of the universe. Even now, the pulsar does not move toward resolution. It does not prepare for an ending or transformation. It remains present, rotating steadily, emitting calmly, and maintaining balance moment after moment. The rhythm continues without destination, allowing the universe to move gently around it. A pulsar exists in a state where repetition becomes comfort. Its steady rotation does not demand awareness, yet it quietly defines its presence in space. Each turn follows the same path as the one before, creating a rhythm so consistent that it feels less like motion and more like a permanent condition. This repetition allows the pulsar to exist without urgency, offering stability in a universe that often feels vast and undefined. The extreme density of a pulsar creates a calm through compression. Matter is packed so tightly that there is no room for turbulence or internal flow. Without movement inside, there is nothing to disturb the star's structure. This internal stillness allows the pulsar to remain unchanged, reinforcing its steady behavior and preventing the emergence of instability over time. The pulsar's gravity does not fluctuate or pulse. It remains constant, holding every particle firmly in place. This unwavering gravitational presence contributes to the star's unchanging shape, ensuring that rotation remains smooth and predictable. There is no stretching or shrinking, only steady containment that supports long-term balance. The magnetic field of a pulsar behaves as an extension of its body rather than an external influence. It rotates with the star, maintaining alignment without drift. This unity between structure and magnetism ensures that the pulsar's emissions remain consistent, repeating the same paths through space with quiet reliability. Energy leaves a pulsar in a way that feels deliberate rather than diminishing. Each rotation releases a small, measured amount of energy, spread evenly across time. There are no sudden losses or irregular changes. This gradual release allows the pulsar to continue its rhythm without strain, preserving continuity rather than signaling decline. The space surrounding a pulsar becomes shaped by predictability. Charged particles move along smooth magnetic paths, slowing and dispersing gently. There are no collisions or bursts of activity. Motion exists, but it is guided and calm, reflecting the pulsar's internal order rather than challenging it. As time passes, the pulsar's cooling continues quietly. Heat fades slowly into the surrounding universe, blending seamlessly with the background temperature of space. This cooling does not alter the pulsar's structure or rhythm. It simply continues unnoticed, allowing the star to age without visible transformation. The isolation many pulsars experience enhances their sense of calm persistence. With little nearby matter, there are few interactions to disturb their rhythm. Signals travel outward freely, maintaining their spacing across enormous distances. The emptiness around the pulsar allows its steady motion to remain uninterrupted. A pulsar's relationship with time feels softened by its consistency. Over decades of observation, behavior remains familiar. Pulses arrive when expected, rotation continues smoothly, and emissions remain stable. This constancy creates the impression that the pulsar exists alongside time rather than being shaped by it. Even now, the pulsar does not anticipate change or resolution. It continues rotating, emitting, and existing in quiet balance. There is no build-up, no final stage, and no conclusion forming ahead. The rhythm simply continues, steady and unhurried, allowing the universe to drift gently around it, while the pulsar remains calmly present. As this gentle journey through the quiet rhythm of pulsar stars begins to fade into the background, there is nothing left to follow and nothing left to understand. The pulsar does not require attention to continue its steady rotation. It will keep turning patiently in the darkness, marking time through repetition rather than change, whether it is observed or not. You may notice your thoughts becoming softer now, less defined, like distant signals slowly dissolving into silence. That is perfectly natural. Just as a pulsar does not hurry towards an ending, your mind does not need to arrive anywhere. Everything important can remain exactly as it is. Let your breathing stay slow and unforced. Let your body rest comfortably, supported without effort. Imagine yourself gently aligned with that distant cosmic rhythm, not pulled or pushed, simply held in quiet balance. There is no need to focus. The rhythm can continue without your awareness. Pulsar stars remind us that even under extreme conditions, stability can exist. Precision does not have to be tense, and repetition does not have to be demanding. Some of the universe's most powerful objects express themselves through calm persistence rather than drama. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel restless, you're always welcome to return to these slow explorations where science moves gently and rest arrives naturally. For now, allow the quiet to remain. Let the rhythm continue beyond thought, and let whatever comes next arrive softly, in its own time, without urgency or conclusion. Good night.